So I want to introduce to you guys the idea of trig ratios. So trig, or trigonometry, is the study of triangles, and the ratios is the idea of looking at comparing different sides. So we could have a really small triangle or a really large triangle, but if the angles are the same, then the ratios of the sides will also be the same. So maybe say let's take like a pretty small 45, 45, 90 triangle, and let's go ahead and just call our units to be inches so that it's small. So I'm looking at 3 inches and 3 inches, and then the hypotenuse, if you remember your special rectangles, will be 3 root 2. And if I were to look at the ratio, which is the comparison of two different sides, if I divide one leg by the other leg, so 3 divided by 3, well, that would be 1. And let's compare that with maybe a really large triangle. So maybe we'll make our units here miles, and it'll be 100 miles by 100 miles. And then from our special right triangles, the hypotenuse across from 90 is going to be 100 root 2 miles. And if I were to compare the same ratio that I did in this one, a leg divided by a leg, and if I were to do that here, a leg divided by a leg, well, check out what happens. 3 divided by 3 is 1. 100 divided by 100 is 1. So no matter whether you're talking about a really small triangle, but 3 inch by 3 inch triangle, or a really large triangle, 100 miles by 100 miles, if your angles are the same, a 45, 45, 90 and a 45, 45, 90, then your ratios are all going to be the same as well. And so this idea that knowing the angles helps us to know the ratios can help us to solve any triangle that we need to. So if we know an angle and a side, then I can solve for the other sides of the triangle. So the first thing we're going to need to understand is different terminology. So let's go ahead and take a look at this blank triangle right here. And what I want to do is I want to be able to label our 3 sides that we're going to use. And I can label one side automatically as the hypotenuse. So across from 90 degrees, across from your right angle, is going to always be your hypotenuse. Now, the other 2 names for the 2 legs are going to be our opposite and adjacent. Now, this depends on what angle I'm looking at. So let me go ahead and start with a theta here. I'm just going to put it there for right now. If I was talking about this angle right here, then the angle that's directly across from it would be my opposite. And the angle that is not the opposite, the other leg that's left, the leg that's next to it, a fancier way for next to is adjacent. I would label that as my adjacent. And so notice that your hypotenuse is always across from your 90 no matter what. The opposite and adjacent depend on what your reference angle is or what your starting angle is. Now let's go ahead and back up. And what I'm going to do is I'm going to change our reference angle, and let's take a look at how that changes the names of the legs. So I'm going to go ahead and change my reference angle, or angle that I'm looking from, to be up here. Now notice that the hypotenuse is always in the same spot. It doesn't matter where your reference angle is, because hypotenuse is always across from 90. But now if my reference angle is up here, then opposite, directly opposite, is going to be down here. So now this is my opposite because it's opposite that reference angle. And the adjacent, the next to side, is just kind of my leftover leg. So my leftover leg. So I would recommend labeling your sides in this order. So number 1, what's your hypotenuse? Because that never changes. Doesn't matter what your reference angle is. Hypotenuse is always across from 90. Across from 90. Number 2, what's your opposite? So what's opposite the reference angle? And then kind of your last leftover side is just your adjacent. And that's it.